In this lesson, you will learn how LED screens create colors, why LCD screens require backlighting, why many televisions advertised as LED are actually LCD screens, and how OLED pixels produce their own light. You will also compare these technologies and learn the key terms needed for exam answers. Screens as output devices. A screen is an output device because it displays text, images, and video produced by a computer system. An LED screen uses many tiny light-emitting diodes. An LCD screen uses liquid crystals to control light from a backlight. An OLED screen uses organic layers that produce their own light, so it does not need a separate backlight. LED screens. LED stands for light emitting diode. A true LED screen contains many tiny LEDs. Each LED can produce red, green, or blue light. The screen changes the current supplied to each LED to control its brightness. Different amounts of red, green, and blue light combine to create many colors. LED screens are very bright, making them suitable for large outdoor displays. LED color and brightness. The brightness of an LED depends on the amount of electric current supplied to it. More current produces brighter light. Less current produces darker light. The same principle applies to the red, green, and blue LEDs. By changing the current sent to each color, the screen can create a wide range of colors and brightness levels. LED television. Warning: you must be careful when using the term LED screen. In a true LED screen, the LEDs form the actual pixels and produce the displayed light. Many televisions advertised as LED televisions are really LCD screens. They use LEDs only to provide the backlight. Liquid crystals still control the image. Remember this sentence: an LED backlit LCD is not the same as a pure LED screen. LCD screens. LCD stands for liquid crystal display. An LCD screen contains an array of tiny liquid crystal pixels. Electric fields change the behavior of these crystals. The crystals either block light or allow light to pass through. The liquid crystals do not produce their own light, so an LCD screen needs a light source behind it. This light source is called a backlight. LCD backlighting. LCD screens require backlighting because liquid crystals only control light. They do not create it. Older LCD screens used cold cathode fluorescent lamps known as CCFL behind the screen. Newer LCD screens often use a matrix of small blue-white LEDs as the backlight. This creates brighter and whiter light behind the liquid crystal display. Advantages of LED backlighting. LED backlighting reaches maximum brightness almost immediately. It produces whiter light, which can make colors appear clearer and more vivid. LED backlights can produce brighter displays, allow thinner monitors, consume less power, and generate less heat than older CCFL backlights. When writing an exam answer, call this type of screen an LED backlit LCD. LED compared with LCD. A true LED screen uses LEDs as the pixels. The LEDs emit light directly and combine red, green, and blue to create colors. An LCD screen uses liquid crystals to block or pass light. It requires a separate backlight, which may use LEDs or CCFL technology. LED screens are often used for large outdoor displays. LCD screens are commonly used in monitors and televisions. OLED screens. stands for Organic Light Emitting Diode. OLED screens contain organic materials made from carbon compounds. Thin organic films are placed between two electrodes. When an electric field is applied, the organic layers emit light. OLED pixels generate their own light. This means an OLED screen does not require a separate backlight. OLED structure. An OLED screen contains several thin layers. These include a top glass or plastic layer, a metallic cathode, an emissive organic layer, a conductive organic layer, an anode, and a bottom glass or plastic layer. Electrons and positive charges move through the layers and meet in the emissive layer. Energy is then released as light. How OLED produces light? A voltage is applied across the electrodes. Next, electrons and positive charges move through the organic layers. When the charges meet in the emissive layer, energy is released as light. The light from many pixels forms the image. OLED screens produce their own light, so they do not need LCD technology or backlighting. Thin and flexible OLED screens. OLED screens can be made very thin because they do not need a separate backlight. Their organic layers are thin and can be placed on plastic rather than glass. This allows manufacturers to create curved, folded, or bendable displays. Examples include curved televisions, foldable phones, and so on. OLED advantages. OLED screens can be thinner and lighter than LCD screen. They can also be flexible enough for curved or foldable displays. Thank you for watching. Like and subscribe for more IGCSE Computer Science revision. Visit www.tuitionharbor.com or email hello@tuitionharbor.co.uk.